Thanks everyone for coming, both in person and online. Today I want to talk about the modern data stack, what that's meant in my experience, how I've used Databricks, DBT, and Fivetran here at Nordic, and also just a couple other things I've learned, again, in my experience using the modern data stack. For those online, I'm doing air quotes. So agenda, I want to talk through just a brief introduction about myself and the modern data stack. Then I want to talk through some example requirements, both requirements for Nordic and requirements that I had for myself in the work that I've done to date with these tools. And then I'll talk through some pros and cons of some things that I've learned along the way. And I'll also show some end-to-end examples in our environment. And then I'll save some time at the end for some questions. So a little introduction about myself. My name is Evan Phillips, lead BI architect here at Nordic. I've been with Nordic for about 3 years now, 5 years total in the BI world. And all of those 5 years have been in the cloud, and mostly in Azure specifically. So I've worked with everything from Azure SQL Database to Azure Data Factory to Azure Synapse, Power BI, anything analytics related, I've probably used it in the Azure sphere. Within the last 2 years, I got certified in the DP 203 Azure Data Engineer course that Azure puts on. And moving forward at Nordic and beyond, I do have an interest in really learning the Data Vault 2.0 methodology. At a previous Madison user group presentation, there was a Data Vault presentation that really piqued my interest. And so really interested in learning more and actually implementing one of those here at Nordic. Introduction to the modern data stack. What is it in my own words? Based on a lot of the research I've done and in my experience, it truly is a buzzword, right? What is modern today might not be modern tomorrow or next year, and what was modern 10 years ago might not be modern today. But really, in everything I've read and all of my experiences that I've seen so far, what it really has meant recently, and when I say recently, I mean within the last 10 years, is it's really been a reduced barrier to entry for scalable analytics in the cloud via cheap native MPP technology and cheap cloud storage. And that really started with the launch of Amazon Redshift in 2012, being one of the first cloud data warehouses, and then following suit with the likes of Snowflake and now Synapse and now Databricks. And on top of that, you have all of these other third-party tools. One of them today that I'll talk about being Fivetran and another being DBT, that really allow you to truly be modular and allow you to kind of pick and piece together different tools to fit your needs and your requirements. And so that to me is really kind of what the modern data stack is. It's not really a true stack that you implement or anything like that. It's an idea, which might kind of sound cliche, but there is a great article out there that Tristan Handy from DBT wrote, and I can provide the slides to my presentation, and that link is in the slides here. And he dives much more in depth about the history and where we were and where we are. And I thought he made a lot of great points. So just plugging that article. So I do want to talk a little bit about the task at hand for myself here at Nordic. Starting out at Nordic, for the past 3 years or so, I've really been a BI team of one. So it's been myself, and within the last couple of months, we've really started to gear up and hire some more developers and some BAs to help implement an enterprise operational data warehouse. And I was really given the reins to decide how to go about building it. So had a lot to consider in terms of the tools we use, what methodology we use, how we're even going to get all the data we need. And I did go down a couple rabbit holes, to be honest, up front. We started developing everything in Synapse, Azure's kind of flagship warehouse. And what I found was, it's a great tool, but it wasn't for what Nordic needs. So I think the big lesson that I would say right up front with a lot of these modern tools is there isn't a one-size-fits-all tool. Your requirements will really drive what tools you should or might want to use. And that includes your own requirements, right? So I'll talk about Nordic's requirements and my own requirements for how I wanted to go about implementing this project. So for Nordic, we consider ourselves a mid to large size company. We're right around 2,000 employees right now. We have a lot of source systems, at least for the type of work we're doing. So as a professional services company, especially in recent years, we've bought many companies who also have source systems. So, we might have 3 or 4 HR systems, 3 or 4 financial systems that all need to be integrated and may have duplicate data across systems. So we need to make sense of all of that in one location. So one of the major requirements, which we haven't had in the past, was dev, test, and prod environments, which might sound like obvious, but for the longest time, we were developing everything in production, right? That's easy, and so we wanted to move away from that and put in a true dev, test, and prod environment. At least that was a requirement given to me. Nordic is a pretty much all Azure-based. All of our infrastructure is based in Azure, so the preference was to have Azure first-party services. So thinking like Data Factory, SQL, Azure SQL databases, all those kind of things would be the first preference. And then outside of that, it was really left up to me to just decide what kind of third-party tools could fit. But I also, really, I didn't shy away from that requirement because Azure does have really great integrations between all of their tools. So that also just made sense to me. When I think about something like a cloud platform like Teradata, they might not have better Azure integrations than, say, Synapse, right? Synapse is Azure's flagship, so the integration between tools is just going to be better natively. They also wanted something cost-effective, right? So when I think about some of the tools out there like IBM DataStage and Informatica, their pricing says contact sales. They don't put a price on their website. And, with a lot of the research I did, come to find out you can run a bill of $100,000 a year or more, right? And so we wanted to stay cost effective and not really below the bank, so to say. We also wanted to implement a data governance structure, including documentation and data quality checks. This is something that was pretty new to us. For the longest time, it was really just, fix things as they came along. But we're getting to the point where we truly need that data governance structure. And there are some unique things in some of these tools that allow you to do that much easier than putting together your own manual documentation, for example. Some of my personal requirements included taking a software engineering approach. So I do have Agile up here. And what I really like about the Agile methodology is the ability to have that continuous improvement, continuous deployment through version control systems like GitHub, Azure DevOps, that kind of thing. And so everything we do is backed by Git of some sort, whether that's in GitHub or Azure DevOps repositories. And that allows us to have our dev, test, and prod environments much easier. We can do development. We can have multiple developers developing on the same code at the same time, which is something, again, that That may seem obvious, but it's something we hadn't had in the past. Another one of my personal requirements was to not reinvent the wheel where possible. So what I'll show with Fivetran is, one of our major systems that Nordic uses is NetSuite, is our ERP, CRM, you name it. It's the system we use for everything. And to get data out of some of these systems could require a lot of time writing APIs to pull data out, drop it in a data lake storage somewhere. And so with Fivetran and some of these other ingestion tools, you don't have to write that. They've already written it for you. So don't reinvent the wheel wherever possible. If somebody's already done it, use that and add on to it where possible. And then this is just a personal preference of mine, was to avoid low-code, no-code solutions. I'm a SQL and Python developer at heart, so I just love writing SQL and Python. I will give a plug for Azure Data Factory. I think that's probably the best low-code, no-code tool I've worked with by far. But so that was a personal preference of mine. Again, that may not be another architect's preference, and they may prefer some sort of integration tool that is very GUI based. And so when it comes to the modern data stack, what really starts to occur is you have all sorts of different tools that fit into the end-to-end analytics pipeline that all do similar things, right? So when it comes to ingestion, those tools listed there are all pretty similar. When it comes to storage, again, cloud data warehouses, data lakes, and lake houses, which again is another buzzword, all do very similar things. They're all based on very similar technology. And then analytics platforms, again, Tableau and Power BI, if you know one, you know the other probably. The clicks might be a little different, but again, the systems are the same. So when it comes to picking a stack, you have options. You're not really sucked into one tool or the other. It'll really be driven by your requirements. And so one of my big requirements was having a connector already built for NetSuite, because the amount of time it would take me to develop some sort of an API, whether it's in Data Factory or Python, to pull data out at scale from our NetSuite environment would have taken me months. And with Fivetran, it took me 10 minutes to put in my credentials, put in my NetSuite credentials, and pull our entire NetSuite infrastructure out into our data lake. From there, had to pick the data warehouse solution, and so was picking between Snowflake and Databricks, and also just SQL Server. Nordic doesn't have terabytes of data by any means. I mean, we're probably within the gigabyte range. And so SQL Server definitely could have made sense, but something that really drove decision here was that Fivetran, who had the NetSuite connector, doesn't have a SQL Server destination or sink, right? Which was kind of odd to me, but yeah, a lot of these tools go with the big data warehouse platforms. So Snowflake, Databricks, Redshift, Google BigQuery. So those are like the big four for data warehousing, but not many of them have SQL Server as a destination, which I found odd. So I ended up going with Databricks because it is an Azure first-party service. In Azure, you can create a Databricks resource, and it comes with a workspace, and it's backed by an Azure storage account. Whereas something like Snowflake, you have to set up your virtual machines and a lot more infrastructure around it to get it to work in Azure. So Databricks was just the easier path of least resistance there, and also came with some other functionalities that I was intrigued by with their data engineering side of things, but also their SQL side that we can talk about here in a minute. And then DBT was the one that I kind of stumbled upon by doing some research into Fivetran, which I have absolutely found to be one of the best tools I've ever worked with. And I think if I'm doing any analytics project, I think I would advocate for using DBT 100% of the time. Doesn't matter what data warehouse platform you're on, DBT can work with all of them. And it's just been a great tool to work with. And so with a lot of these new tools, they really lend themselves to, rather than an ETL architecture, an ELT architecture. So extract, load it somewhere, and then do your transformations. And this kind of goes back to my first point about the reduced barrier to entry, right? Cloud storage is extremely cheap. So you can store your entire system in a data lake for dirt cheap, right? We store all of our system data in our data lake for less than $100 a month. And so with Fivetran, we connect to our source systems, pull the data out, drop it in a data lake, and then Databricks and DBT pick it up from there to do the transformations. And so that's a bit different than the ETL architecture, but these tools just lend themselves more or easier to the ELT architecture. And so the tools on this list here are not comprehensive. Obviously, Azure Data Factory is a great tool for ingestion, storage. You could easily use SQL Server with Azure Data Factory even. And then analytics, Power BI is missing. I've always been a Power BI person. So that is what we use here at Nordic. And so what DBT offers us as well is also that testing and documentation right alongside our code. So it is, for all intents and purposes, a self-documenting tool. And then you just add color commentary to what it already provides you out of the box. And so with DBT, you can just take your raw data. All you do is write SQL models. So you write select statements, essentially. And DBT handles all of the DDL for you. So if you want to materialize something as a view, you just tell it you want it to be a view. If you want it to be a table, you tell it you want it to be a table. If you want it to be incremental, right? You don't have to spend time writing the store procedures and all that to handle creating the table, handle schema evolution. DBT handles all that for you. So with that, I will dive into.
So does that mean that it's generating that transformation code for you on the platform you're on? So in this case, if it's Databricks, it's behind the scenes writing the Python code?
Correct. So DBT by nature is a SQL compiler. And so it compiles the SQL and then runs it in your destination of choice. So in this case, Databricks has a SQL engine. And so DBT compiles a SQL, sends it to Databricks, runs that SQL in Databricks, and materializes any models or anything in the database that we tell it to be in, right? So starting from the front, we can see here in Fivetran, we have an interface to set up a destination. So this is where we set up our Databricks on Azure. And so we just fill out our connection credentials. So you get your server host name, access tokens, endpoints, all that stuff to tell it where to send the data. Then from there, you set up your connectors, right? And so Fivetran has a whole host of SaaS applications that they have already written connectors for. And so this is a big selling point for me because they had a lot of the source systems that we use already. And so I don't have to spend the time writing the APIs for these to get the data out. They've already done that. And so for Salesforce, for example, we go in, give it our login credentials. And in this case, all I had to do was authenticate to Salesforce. And then Fivetran goes and determines the schema. And so you can pick the tables you want. So you just click the checkbox. You can pick specific columns if that makes more sense for you. At any point, you can resync just a specific table, or you can resync your entire connector. And what Fivetran will do is, based on each source system and the destination, will do change data capture for you to determine which records have changed and drop them in your destination with a load date timestamp. Oh. Good. Cool. Yeah, so what I was showing before was for Salesforce, for example, it will go find the schema of the system. So you can pick and choose which tables you want. It'll also find columns, so you can pick specific columns. And on top of that, you can hash columns as they come in. So if you have PHI or something, you could hash it on the way in. So, you can hide credit card numbers or anything like that as it comes into your system. You get charged by monthly active rows, and that's based on in a single month, every time Fivetran sees a new ID, it considers that a monthly active row. But if it sees it again, it only counts that ID one time. So if you update a single record 1 million times, you're only going to get charged once in that month. The next month, you'll get charged again for that record, but it's on a sliding month window. Yes, so it's distinct within the month of the record, right? So, and that's their way of controlling costs to you, right? If they charge you for every time a record changed, it would be through the roof. They don't, because you pay for storage, right? They're just taking the data and dropping it in your destination. So whatever you get charged in your destination, that's what you get charged for storage. So in this case, they're dropping it in Databricks, but really, and we'll talk about this in a minute, but our Databricks instance, the data warehouse is built on top of a data lake. So we're paying Azure storage prices, which is dirt cheap for us. So for us, it makes sense to pull all of our data always and just have everything in our data lake to run transformations on. So you can see usage for every new connector you create. You get 2 free weeks to get an idea of what your usage would be. And you can see the first of the month usually sees a spike because that's the first day that it's seeing new updates. And then after that, every day is pretty minimal, depending on how many transactions you may be seeing in a day. And so your usage within a month for Nordic, we're in the gigabytes of data range, and we're paying around $300 a month for Fivetran. So from there, from Fivetran, it sends it to your destination. And so for us, that would be Databricks. And so in Databricks, this is where we'll get our first look at the different identities within Databricks. So this was a big thing for me in terms of a selling point for Databricks, is that they have not only their data engineering side, which they've had for a long time, but they've now introduced a SQL identity, which you can do all of your SQL workflows, much like you can in things like Snowflake or other cloud warehouses. And it's all ANSI SQL standard. So the language from one cloud warehouse typically works in another as long as you're following the ANSI standards. Want to make sure I slow down for any questions, if there were any from Fivetran, before we dive too far into Databricks here. So for Fivetran, what it is doing is dropping all of our data into each source system database. So our NetSuite connector goes to the NetSuite database, and this is what we consider to be our raw data or our source data. Databricks talks about a medallion architecture, so you'll have bronze, silver, and gold. Our source systems can be thought of as bronze. So very raw, however it comes out of the system, that's what it says. Fivetran also does a lot of normalization. So in the case of NetSuite, if there are things like dropdowns, it'll split those out into a separate table so that you can have certain key associations and all that kind of stuff. And that's where DBT comes in then, at least for us. And so before I get too far into the T in our ELT, I do want to talk about the Databricks data engineering identity. And so this is, at one click, you are now in a completely different working environment where you can write notebooks in either Python, Scala, or there's another one that I can't remember off the top of my head, but it's all based on Apache Spark. So you'd be writing PySpark, Scala, and whatever the third one is, can't seem to remember it. But so for us, we had some source systems that didn't, that weren't already created in Fivetran. And so for myself, I could have done this in Data Factory as well. And in fact, we do have a Data Factory instance to ingest things like Excel files if we need to, or ingest things that aren't in Fivetran and also just wouldn't make sense to write Python for. So we kind of have the whole ecosystem going on in terms of Fivetran, Data Factory, and Databricks in terms of ingestion. And so what we can do is write our own, in this case, API for a specific system. And it's all notebook based. So if you're familiar with Jupyter Notebooks, you can write your own Python. And something that is new to Databricks now is you can write your own Python modules and then import them into other notebooks. So in this case, I wrote a Personio module. Personio is one of our source systems. And so I just wrote the APIs for each record that you could pull because they do have different URL paths and all that kind of stuff. I could refactor this to make it a bit more parameterized and whatnot, but this was quick and dirty and got the job done. And now I can reference these functions in other notebooks.
What is this system, Personio?
Personio is an HR system. I think it's based out of the Netherlands.
Yeah, I see the .de.
Yep.
So it's got to be one of our European companies. Yep. Cool.
And so what's awesome about Databricks as well is you can natively interact with Azure Key Vault. So I don't store any of our passwords or tokens or anything in here. You can just set up a secret scope to then look into Key Vault for any of your secrets. And I know Jason's on this call, so I just wanted to point that out. Cool. I also created some utility functions. So turning column names into snake case, other things. But yeah, so you could create out an entire library that's all parameterized, certain functions that you want to do in Python that maybe you can't do in other things. I am a huge Data Factory fan, but there are just things you can't do in Data Factory that maybe you can do in Python. A great example I have in our current project is doing master data management using fuzzy logic. So there's a Python package called Fuzzy Wuzzy that I want to use that I'll be playing around with here in the next couple months. So this is the data engineering side. And for setting up recurring jobs, all that happens in workflows. here. Cool. So you can then set up a job with tasks. So this would run one Python script. You can have them be dependent on one another. So this would be the essentially the same thing as running a pipeline in Data Factory, but it's all code-based. You can set it up on a schedule just like Data Factory and whatnot. And all of this is driven by clusters. And so you can set all sorts of different cluster parameters. You can set the size and the memory and have different settings there. You can import libraries to a certain cluster. So if you need to do generic work, maybe you'll set up like a generic development cluster like we have. Or if you have a really heavy workload pipeline, you could set up a different cluster that has, much more memory or something on it to be able to handle that heavy workload if needed. So from there, they do have a machine learning module where you can set up feature stores and machine learning models. I haven't dug into this much at all. I think it'd be nice someday, but I don't think Nordic is quite there yet. And so what we use by far the most right now is the SQL workspace. And so what is unique to Databricks is that they are all based on that their storage mechanism is all based on what's called Delta Lake. And so if you're familiar with the Parquet file format, what Delta Lake is just a JSON log on top of Parquet files that tracks basically every change that happens to a table within it. So when a change happens to your Parquet files, it doesn't actually update the data in the Parquet files. It just adds a new Parquet file, and then in the JSON log says this Parquet file or another Parquet file is no longer relevant. So ignore it when you read the table. And so in our data lake, what this actually looks like. So we'll take NetSuite, for example. So we have a bunch of Parquet files and then a Delta log on top of it. And so each of these JSON files will tell us which Parquet files are relevant at that point in time. And so at any point in time, you can time travel back in time on your data to see what your table said at a point in time. So this is effectively kind of like a subtly changing dimension, but not quite. It's Delta's take on it. And so the other caveat here is that Databricks is not based in a relational database management system that is row-based. It is columnar and compressed in Parquet files.
Do you perform any kind of like cleanup routines or something? Like, let's say after a couple of years, any of the older stuff might not be as important, so do like a compress or something?
Yep. So there's a function called vacuum that'll suck up any files that are old, and you can set a like a date range, say like vacuum anything older than 30 days. For Fivetran, they do that on weekends. So every weekend they go run vacuum operations on all of your tables for you. So we don't have to worry about our raw data. We do have to worry about the transform data though. But I'll show in DBT where you could handle that automatically. So the actual compute power in Databricks SQL comes from SQL endpoints, which are essentially a cluster made for SQL workflows. And so it's the same concept. You can determine a size, which is your compute power. And the nice thing about the SQL endpoints is you can turn them on and off, and you can also set parameters around, like if it hasn't had a query in the last 10 minutes, shut it down. And so that'll save you on costs as well. But also at any point in time, you could just have your SQL endpoints running all the time if you have query windows that span 24 hours. So from here, we have all of our data in Databricks in our raw databases. And so now we need to transform it. And so rather than actually writing the transformations in Databricks, we can go to DBT for that. And so what DBT is, and specifically what we're looking at here is DBT Cloud. DBT is an open source project that is based in Python. So you could run this on the command line if need be, and publish it in a Docker container or something else. But DBT provides a cloud IDE that you can use, and that is what we prefer to use for now, just because it's a lot easier for us. So in DBT, it's structured, in a file-based project, and so all of this is backed by Git again. So what you're seeing here in this file structure is in Azure DevOps repositories. And so we create branches off of this and do commits and pull requests to get our models that have any changes on them back into like our development branch or our main branch to then run on our production database, for example. So right now I'm in our dev branch, which for all intents and purposes is our testing area. And so for DBT, it is, like I said, all based on select statements. So you're not writing store procedures or anything like that. You're just writing select columns from model, doing any transformations you need, and then DBT handles materializing it as whatever materialization you tell it to, right? With the added kicker that it also uses Jinja, which is a templating language in Python. So what Jinja allows is the cross-pollination essentially of Python and SQL at the same time, which is pretty cool. And so one of the first things you see when you come into DBT is this example here. Zoom in a little. And so these curly braces with the % is a Jinja command. And so you can see it's similar to Python in the sense that you're writing a for loop. So what this is saying is for a number in a range from 1 to 10, we're going to select that number as our column. And then we're saying if it's not the last loop, we're going to union them, and then we're going to end if. And so what this turns out to be when we compile it is select 1 as my column, union all, select 2 as my column, right? And so on and so forth. So you can get really creative with this to be able to create really generic files that you can use as templates to create models downstream in a consistent and scalable fashion, right? And so this is a very simple example. One thing that we'll look at here in a minute is an example of creating a data vault resource, like a hub, a link, or a satellite, just by providing metadata. And so what that leads me to is looking at a model here in DBT. And so if we look at an example of a transformed model, we'll just take a generic one here. So this is one of our staging models where we're taking the raw table, determining which columns we want using a macro. And so a macro in DBT is essentially a function. So let's say you consistently change cents to dollars. You could write a function that says, it's the equivalent of like a UDF in SQL Server would be a macro. So we have a macro that's getting our staging columns. And then we have another macro that's saying, if we have any pass-through columns, bring those in. And then we have our final model. And so all of this SQL is nothing more than a select statement that would get compiled. And the SQL that gets compiled based on the materialization of the model, and when we say model, we mean the file. That's what will happen in Databricks. And so in this example of our DBT project, we determine what the materialization is at the folder level. So for example, everything in the core folder gets materialized as a table. Everything under staging gets materialized as a view. There's also ephemeral, which would just get, it doesn't even get materialized. It's just materialized as code within code. And so from, yeah, I think it's spinning up my endpoint. Yep. So we have a different endpoint for DBT Cloud. And so when DBT goes to compile something with our Databricks instance, it'll spin up this endpoint. So I had our BI team dev running before. No, the compiling usually takes like a minute. Not a minute, sorry, a couple seconds. But so what DBT also does is generates self-documentation. And so there's a command within DBT that you can run just called dbt docs generate. And it'll go through all of your models and scrape the metadata around it and create this nice documentation site for you. And what this comes with out of the box, which is one of my favorite things, is a lineage graph to show you all of your models and how they're related to one another. And so if we look at one of our fact tables, so we have fact bookings. We can see all the models that go into our bookings fact table, right? So any green nodes represent a source system. Any blue nodes represent a different model that's transformed. And you can see how all of them relate to one another. And so this is our service offering model that gets transformed along the way. And to do this within a specific model, what you would do is use a Jinja function called the ref function. And so that's exactly what we see here, where in the from statement, you're not actually referencing a table name. You're putting in the model name, but agnostic of the schema, right? So in this case, DBT will know that I'm in my development environment. And when I go to run this model, it'll create that model in my development environment. But then from there, I might create a production job that'll drop that model in a different database. So it's all based on the profile that you're coming from, right? Let me try compiling this again. Cool. And so this is a little messy because of the way the macro is set up, but this compiles all of our SQL and drops it. It will drop it when we run it in our DBT Phillips schema. So when I'm logged in and I'm developing in my development environment, it knows to look in this DBT Phillips schema. But when we go to run this in production, it may switch this DBT Phillips to prod or something, right? And that all happens based on our job. So we have environments, we have our development environment, continuous improvement, and production. So in production, we can set up a job, which will then look to you can point it to a branch from your repository. So remembering that all of our code is backed by a Git repository in Azure DevOps here. And so anything that's in main is what our production environment runs on. Anything that's in dev is what our test environment runs on. And then any feature branches is what our development environments run on. So when we go to set up jobs, we can point each job to a different branch, right? So in this case, it's running on main. If at any point we wanted to test something in CI, we would point that to our dev branch. So let's say one of our developers has a really cool feature, they do a pull request into our dev branch. We can run a full test on that, which would bring it to our CI database. So in this case, CI is our test database and analytics is our prod. And so we can, in one click of a button, rerun our entire warehouse top to bottom and refresh all the data, refresh all the models, all from DBT. And so let's look at an example. I want to be mindful of time. How long are we going till? Cool. Okay. So models do rely on one another in DBT using that ref function. So typically what we would see for running something in development to test the full pipeline, you could run models at any point in the pipeline. So thinking about our graph that we were seeing. So if I look at our dim business line model. So our dim business line model relies on all these models before it. And so you could think of this as a pipeline, right? So I could run this pipeline at any point in the pipeline with just one command here by saying dbt run. We'll do select dim business line. And so this command would just run that model, or we could put a plus sign in front of dim business line, which would run every model before it and that model, right? So if I run this. So if there's transformation logic that needs to happen before this model, this is how you would do this. So all I did was write the SQL statements. And so now DBT is taking care of all the DDL. So a lot of these are just views. So likely what it's going to wrap around it is create or replace view. If it was a table, it would say create or replace table. If it was incremental, it would handle the schema evolution with it. So if you added a column, it would add the column for you. And then also handle the inserts, upserts, that kind of thing. Something new to Databricks or unique to Databricks is the concept of delta merge, which is the equivalent of an upsert. And so in each of these models, it could handle different transformation logic based on the select statement you write. And so this V stage, we'll look at that one more in depth here because that is an example of a data vault model that we created using only metadata. that one's taking a second. So in here, you can see the actual SQL that it ran. So it gives you all the log information here. So you can see creator, replace view, and then the code beneath it. And then dim business line should be a table. So creator, replace table. And all I had to do in my DBT project was let it know how I want it to materialize. And then it handles all of that DDL for me. So looking at a data vault example, we'll look at a hub here. So one thing that is pretty cool about DBT, being that it's open source, is that you can bring in packages that other developers have already written. So again, going back to one of my requirements of not reinventing the wheel, there's a company out there called, I believe it's Data Vault UK from the United Kingdom, that wrote a DBT package specifically for data vaults. And so what I'm able to do in my DBT project is bring in all sorts of packages. And so you'll see a couple in here that Fivetran have written, and a couple utility packages. And so what this allows is Fivetran had already built out staging models for a lot of the SaaS applications that we use. So Salesforce, NetSuite, they already wrote the models that clean up and recast the columns and all that kind of stuff. So all I had to do was bring those in, and you can see those here. And each of these packages themselves are their own DBT project. So it becomes very modular in the sense that we could create a DBT project that only has macros in it, that are utility functions that we might use across all of our DBT projects. And so for this DBT Vault example, that's exactly what this is. It's just a project full of macros that all are intertwined to help create data vault models. And so this example of Hub Business Line, this is the code that's required to compile the SQL needed to consistently do all the hashing, add the columns and all that kind of stuff to create a hub model in your data vault. And so what this allows is really quick and automated development around adding entities to a data vault, in this example, very quickly, because all I have to do is write the metadata, say, here are the models that I want included, here are the columns I want included, create the SQL for me and go. So this very quickly turns into an automation tool that somebody else wrote for me, kind of thing. And so, to handle different connectors, so Databricks versus Snowflake versus BigQuery, based on the connection you set up in your DBT project, it'll know what platform to write to. So it'll know what language or dialect to write the SQL in. Snowflake is slightly different than Databricks, which is slightly different than BigQuery. So they all have their own little macro nuances to handle the differences in the dialect. So for example, in this DBT, in this data vault package, they have Databricks macros, but then they also have BigQuery macros, which generate the same SQL just in the dialect of the platform that you're on. So I provided this metadata, and it generated this SQL. This isn't a very impressive one, but there are some really cool ones that'll generate hundreds of lines of code, all by you just providing some metadata. And so this could allow, instead of an entire, 10, 20 developers putting in a data vault, could potentially have 1, 2, 3 developers working on it. And all at the same time, right? Based on our software development practices with Git.
So because it is a code generation tool, have you ever found yourself looking at the generated code and be like, oh, I could have probably written that better myself? Does it do a pretty good job?
Yes and no. So at times I have seen that, but since they are open source, I've actually forked some of those packages, made the updates I would make, and then done pull requests, and they've actually accepted them. So Fivetran, for example, has their packages just publicly available. So I forked the NetSuite one, said, hey, there's some weird stuff going on in here, made the fixes, did a pull request, and they had it synced up within the day. So I was able to make my own changes to somebody else's code base that I was able to then pull back into my project. So that is one, I guess, pulling everything back to my presentation here. For the pros and cons, I would consider open source to be a major pro for a lot of these tools. For an example just like that, right? If you find something that's weird or maybe broken, you can take bug fixes upon yourself or someone else's code that's out there. It's very modular. So if we don't like Fivetran in the next couple of months, we could move to something like Stitch or just use Azure Data Factory or just use Databricks, right? And we'll still be okay. Our entire platform isn't on one product. A lot of platforms are moving that way anyway, but I think about the days of you could have your entire platform in Informatica potentially, or IBM. It's very cost effective. Everything we just saw in DBT is free. You don't pay anything for it because it's open source. It just runs on the command line. So all you're paying for is the compute power in Databricks that's used to generate those tables and everything. So all in all, for our entire infrastructure, we're spending less than $1,000 a month between Databricks, Data Lake, Fivetran, everything. Some cons, I would say, having some different software and different applications, personal preference, I'm okay with that. I'm okay going to DBT Cloud to do my SQL development, and then check it in Databricks, and then go to Fivetran to get connectors set up, and then Data Factory if I need some custom integration. Can also be very code heavy, obviously. I'm okay with that. I like that, but that may be a con to other developers out there. It can also be very bleeding edge. So everybody we've hired so far, we've had to train on Databricks and DBT. But again, as long as you know SQL and if you know Python, you can fit right in. You just need to know the clicks. And then lastly, kind of similar in the same vein as the first one, there's no single pane of glass, right? So you can't run an entire pipeline and check your data in the same place. But yeah, I want to save time for questions. I know we're over time already though. And I feel like I touched on a lot of things, but didn't go very deep in anything. Yeah, thank you.
Do you want to use the mic if you turn it on?
I was interested what happens when you've got some bad data. How tough is it to find it?
That is a great question. And so it can be tough to find, but what DBT allows is for unit testing. So you can write tests that you can then, as you're running your job, one of the commands you can write is just DBT test. Right, so if I had a test on one of my models, and so the way you write tests in DBT is just using SQL statements still. So let's say, for example, I didn't want, or I wanted a column to be unique. DBT has out-of-the-box tests, but you can also write your own custom tests. So an out-of-the-box test might look like, and this is one thing I didn't touch on, but I probably could here for a quick second, is all of the documentation lives right next to your SQL code, and it's all YAML based or YML file based. And so you just describe each of the items you're using. But specifically in your models, you can write generic tests right in the documentation. So on my application ID, I want it to be unique and I want it to be not null. And so as I run my code, before I even run these models, I can test them first. And if anything fails, I can say, stop, don't move forward, right? So unique and not null are two of the most popular ones probably by far that are out of the box. DBT has a lot of great documentation on other things that they have. So there's like, the number of columns need to match in two models, all sorts of things like that that you wouldn't have to recreate the wheel on. But if there are unique scenarios where you really need to test something, like if you had a salary column that you needed everything to be over $1 million or something, you could write a test for that and then test it against your data. That's unique to your data. And so this is one thing that we really want to start doing much more of moving forward in our project, is unit testing right alongside the code.
Can you talk a little bit about the data? So Fivetran, for example, I'm assuming the data actually goes into the Fivetran cloud or something before it makes its way to the destination. So it is leaving your borders, essentially.
Yep. So you actually set that up in your destination for Fivetran. So we have our destination as Databricks, and then you also set the cloud service provider that Fivetran uses. It doesn't go into your cloud tenant. So I set it up in Azure, but that means that Fivetran sets up an Azure tenant for themselves to move our data into for staging to then move into our destination. And they describe in their documentation how that whole process works.
Mm-hmm.
But they are like SOC 2 compliant, HIPAA compliant, all that kind of stuff. And I think they only, for certain connectors, they would only ever keep the data for 30 days. Most connectors is in and out. But for some connectors to do change data capture, they have to keep it in there.
Yeah, I would imagine for CDC stuff, it's holding on to like keys and hashes or something, right?
Yep.
Interesting. And then DBT, I saw that it was running in your cluster, and it looks like the only thing that's on it is just the code.
Yep. So all it does is generates the code, and then you provide it credentials. So in this case, I was using a personal access token. And then you can see in the query history that DBT just actually goes and runs the code just right in Databricks. So this may look different in a different cloud platform. Create or replace view. This might look different in like Snowflake versus BigQuery. But in Databricks, you have all the query history here where you can go validate the actual SQL that it ran. And then true end-to-end, we get everything using DBT into our star schemas, and then bring those into Power BI to build dashboards and reports off of. which is the sizzle, right? It's the fun. But cool. Any other questions?
Thank you.
Yeah, absolutely. Well, everyone online, thank you for joining. I don't know if Jason's still here. I hope I was secure enough for you.